For the first time ever on Blu-ray, Rock Mechanics' original vlog, The Final Turn Project. 3 men left in the mountain, the friendship that lasted a lifetime. Introducing our actors.
안녕 후은 양첸영 무하마드 다니시 아시라프 로자이만
Starts now.
삼성산 준비 갈 완료.
갈 준비 완료.
예.
준비 갈 완료. 갈 준비 완료.
We started at Gwanaksan-Gongan. And while going up, we could also see a magician. We took some awesome photos too. And we could also see a patriotic young man who does climb the rough rocks very well. And we could also meet a man who cuts a rock with his hand.
Next slice.
There was a Sisyphus holding rock at Samsung Mountain. We also saw a cute cat in the middle of the mountain. And of course, while going up, we never forgot to measure our values. While going up, Chung-Ang told us some interesting information called Chung-Hoon's 이모저모. This topic was about tofu.
양반. 뭐라 해야지? 그때 시절로 하면 닥터. In Joseon there was.
We saw a suspicious marble intrusion line.
There is a marble line connected to that part of this rock.
And after taking numerous stairs, we could reach the summit. And on the way back down, we saw the patriotic young man again. Now going down using 축지법.
정말 빠르다.
After climbing, we ate a delicious eel dinner.
Hello, we're glad to have an opportunity to give our presentation in this wonderful place. Especially thank you for Professor Joe. We went to Samsung Mountain, and I'm the first speaker, Yang. The purpose of using stereographic analysis is this, to determine if structural features dip towards tunnel, increasing likelihood of rock slabs detaching or blocks becoming unstable, and to help to decide safest tunnel alignment, and to predict potential points of water leak, and to ensure tunnel is aligned and minimizes intersection with unstable planes. So in rock mechanics, intact rock behaves like a single material. However, when discontinuities like joint exist, the overall behavior is dominated by these weak planes. So depending on the situation, we analyze rock as either a continuous material similar to soil mechanics when joints are negligible or numerous, or as discontinuous system where joint structures and orientations play a significant role. So this method of analyzing joint behavior is known as structural geology analysis, and understanding the local geology and geotechnical conditions is essential in this process. So the next part will be covered by our second presentation speaker, Danish.
Thank you, Chung-Ang. I will now be presenting the theory for this project. So faults are shear displacement planes within rock mass formed due to brittle deformation of rock-like joints. They are important to predict fluid movement and ensure safety of the ground. To accurately determine the movement and characteristics of a fault, it is important to identify structures that have been offset by the fault on both sides of the plane. There are two main features that we investigated, which are strike and dip. Strike refers to the direction of line formed by intersection of a fault, bed, or other planal features on a horizontal plane. It indicates the attitude or position of linear structural features. Dip, on the other hand, refers to an angle at which planar feature is inclined to the horizontal plane and is also noted to one of its 8 compass points, which includes north, south, east, and west, and also its subdivision. Together, we are able to express this strike and dip measurements into the form of 3 digits and 2 digits. The first 3 digits indicating the strike angle and must be written in 3 digits as its range goes up to 360 degrees, and to prevent confusion with the dip angle. The last 2 digits refer to the dip angle, as the maximum angle achieved is 90 degrees perpendicular to the line of strike. After the 2 digits are written, the compass points which indicate the direction of dip is also written. That is all from me. I will give this to the next presenter.
Hello everyone, I'm Chung-Ang. In my part, I will cover the result and consideration. After we gather the value, we have to pre-process the data. The total stereographic projection using non-pre-processed data is this. As you can see, we couldn't get the tendency of the data. We thought there might be a problem with data utilization on premise that we use the clinometer correctly, and we found some problem and eliminate those values. Spreadsheet 3 GPS points, too many measurements at one point. Yeah. After eliminate those values, we could end up with result with some tendency. And about the consideration, with the distribution of polar dots, we can assume the failure point of log slope. If the dots are distributed in the whole net, it is circular failure. If the dots tend to gather in one point, it is plane failure or topping failure. If the tent has two gather points, it is wedge failure, and we can classify if it is plane failure or topping failure with the selection of slope of discontinuities and slope. As our values are telling the tendency of one point and those are in the opposite side of slope curve, we can know the slope was plane slope. Thank you.